This tutorial is an overview on how to solve gas stoichiometry problems using the alternative method to do stoichiometry. So previously when we've solved these problems, we know that after we've set up the problem, we're setting up our ratio. Anytime we bring down the unit of moles, we write the coefficient. Anytime we bring down the unit of grams, we're going to multiply the coefficient by the molar mass. And now for liters or volume, if we bring down that unit, we're going to be multiplying the coefficient by the molar volume of gas to set up our ratio. Okay, so when I'm reading this type of problem, all the words don't matter except for the given, which will be a number with units attached. And we'll be looking for where it says how much, how many, calculate, and we're looking for volume of ammonia. Okay, STP just means that we're allowed to use molar volume of gas. So for all gas stoichiometry problems, assume that it's standard temperature and pressure, 0 degrees Celsius, 1 atmosphere, which means 22.4 liters equals 1 mole. Okay, so the given is 9 grams of hydrogen. So above hydrogen, I'm going to write 9 grams. Okay, again, the most common mistake I see with students is they make mistakes because they don't include grams. Make sure you include that so you know what unit that you are bringing down. And we are looking for volume of ammonia. So X, we don't know how many, liters. Okay, and I'm going to bring down the unit. Okay, so just like in the previous problems, anytime you bring down grams, you're going to multiply the coefficient by the molar mass. So the coefficient for hydrogen is 3. And then I'm going to look up the molar mass. Okay, the molar mass of hydrogen is 2. Okay, so that's the number I will write next to grams. In the next problem, okay, we've got liters. So if you bring down liters, you're multiplying the coefficient by molar volume of gas. Okay, my coefficient is 2 times 22.4. Every time you bring down liters, you multiply the coefficient by 22.4. That's the molar volume of gas. 44.8. So now I have my ratio. 9 over 6 equals X over 44.8. So 6 times X equals 9 times 44.8, which is 403.2. Divide both sides by 6. Get X by itself. And your answer will be 67.2. If we look back to figure out what the units are, okay, we look for X. It's liters of NH3. Okay, to correct that for significant figures, I see that my answer should only have 2 because the given had 2. So it'd round to 67 liters of NH3. Okay, next example. How many liters of nitrogen, that's what I'm looking for, would be needed to react with 67.2 liters of hydrogen? Okay, again, we're just looking for the number in the question because that's going to have units attached. Then it will say how many, how much, something to that effect. Okay. So we're looking for liters of nitrogen. So I'm going to go above nitrogen. I'm going to write X liters. Okay, how many liters of nitrogen would be needed to react with 67.2 liters of hydrogen? Okay, so I write my given above the molecule that it mentioned, hydrogen. I'm going to bring down my units. Okay. So again, every time you bring down liters, you're going to multiply the coefficient times molar volume of gas. Okay, and this one coefficient is 3 times molar volume of gas, which is 22.4. So 1 times 22.4 is 22.4. 3 times 22.4 is 67.2. Okay, so I have x over 22.4 equals 67.2 over 67.2. Cross multiply, 67.2 x equals 22.4 times 67.2. Oops. Okay, we want to get x by itself, so we'll divide both sides. X equals 22.4. We can refer back to our problem to figure out our units. So x liters of nitrogen. Okay, and we already have the correct number of sig figs.